If you're watching this video as part of my complete SETRI course, then you will just have finished the very first experiment in SETRI. So you saw that programming a treatment is not so hard. It actually is rather quick. But while we were doing that, I asked you to take several things on faith, and I told you to just accept the default options without thinking too much about what this means, because we would get back to that later on. Well, now is later. Now we need to take a closer look at some of these things, and we'll start with the basics of SETRI programming. And what I mean by this is that we'll talk about the variable types and the functions that the programming language offers you, which are pretty standard, most of them, for programming languages. We'll also talk about the structure of a treatment, and we had some of this already in the public goods game. We'll talk about the background, for example, and what settings you can make there and need to make there, and how they influence the remainder of your experiment. And we'll talk about the creation of a stage and how the settings you can make in this dialogue influence what your subjects see on the screen, how long they see the screen, and so on. And finally, we'll also cover loops in SETRI, so how you can tell SETRI to do some commands multiple times. Let's start with the variable types that are available in SETRI. The first, and the one that is used most often, is a numerical variable. Now, it offers a lot of precision, 15 decimal digits, and so on. The important thing maybe is that it's saved in binary format, which means that there are some deviations, minimal deviations of course, but there can be deviations from decimal format. And if you have a variable, well, a number in a variable that cannot be expressed precisely in decimal format, you may see some strange things happening. So you may see in your output file that something is not 15.3, but it's 15.2999999, something like this. Okay, so that's because it's saved this way, but that's, well, that applies to any programming language that saves variable values in binary format. And if you set, well, how do you define a numerical variable? You just put the variable name equals and the number. Yeah, so contribution or endowment equals 20, and semicolon would be the command to set to create a numerical variable called endowment and set its value to 20. The next variable type are string variables. String variables contain text and can be defined by using the quotes, yeah, quotes at the beginning and quotes at the end, and the text is put in between. Boolean variables can only contain the value true or false. So for example, you could create a Boolean variable by saying test result equals x less than or equal to 5, and then SETRI would evaluate this expression here and say, is x less than or equal to 5? And if it is, then test result will be set to true, and if it's not, then it will be set to false. If you want to use true and false directly, just be careful, because remember, SETRI is case sensitive and they need to be in all caps, so all in capital letters. And finally, SETRI has its own variable type for colors. So you can create a color variable that you call, for example, favorite color, and set it to the color that corresponds to RGB 100.5. Yeah, so that's 100% red, 0 green, and half 50% blue. You can also use the standard RGB 255 notation and set it to 255 red, 0 green, 128 blue. That's the same color as above. Furthermore, in SETRI you can define arrays, which is basically a vector of values. And this can be used to save, well, I recommend using arrays for short vectors, yeah, not for very long vectors, because they're saved. Each vector element is saved as a separate variable, or at least it's outputted as a separate variable in the output files, and that makes it a bit tricky to work with this. So I prefer not to work with arrays in many cases, but if but in some cases they make sense. You would define an array as saying array and then the name of the array. In this case, it's called A, and it's set to contain 3 elements. You could also, and these are indexed 1, 2, 3. Now you could also create an array that has the index values going from 1 to 5 in steps of 2. So the indexes would be 1, 3, 5. I don't know where this makes sense. I've never used it. Anyway, once you've defined your array, you can set, for example, the array at, or the vector value at in the second position equal to any number, for example, equal to 10. Okay, forget this part here. And for arrays, it is the case that the default variable type is a real, again, a numeric variable. But you can define arrays for all kinds, for all of the basic variable types, by just saying real array or Boolean array or string array or color array. Now settree allows for all the simple functions that you would expect in any kind of programming language. So it has an if function that allows you to, well, make conditional statements if k is less than 5, or, so that's the logical or, k is greater than or equal to 10, then return 1. So result would be set to 1 in this case, or return 10 otherwise. Then you can calculate the absolute value of something. In this case, there is another function within the absolute value function, and that's the pi function, which just returns the value of pi. You can round the whatever is in the variable a, and the way rounding works in settree is that you tell settree to round to the nearest multiple of whatever is put here. So it will round a to the nearest multiple of 0.2. So if you want to round to the nearest whole number, you would put a 1 here. Yeah, if you want to round to the nearest tenth, 0.1, then you would put 0.1 here. You can also tell settree to always round down or round up by using round down or round up. Random generates a uniformly distributed random variable between 0 and 1. Random Gauss down here gives you a standard normally distributed random variable. And exp is the exponential function. SQRT is the square root. The little hat here is the power function or the power operator. You can use the natural log function. Calculate the natural log by putting ln, and the 10 log by using log. And we also have the max function. The max function can only take 2 arguments, and the min function as well. Now the word if has 2 uses in settree. First, in the if function. That's what we used or saw on the previous slide. You can use the if function to assign one of these 2 values to the variable on the left-hand side of the equal sign. But we can also use an if statement to control code execution. That's what I'm demonstrating here. Here I'm checking whether the value in variable a equals 0. And I need to use equal here as the comparison operator, because if I would write a equals 0, that would mean a should be set to 0. So 0 should be written into a. But here I just want to compare. So I say if a equals 0, then b will be set to 1. Then I can check if a instead is 1, so that's where this else if statement is for. So if a is not 0, settree will check whether it is 1, and if so, it will set b equal to 5. And in all other cases, it will set b equal to 3. So that's where this else statement comes in. And of course, you can use only if, you can combine if with else if, or multiple else ifs, and you can have an else statement if you want, but you don't have to. Furthermore, for any program, we can set a condition for this entire program to run here. So if here I would write a equals 0, then this entire code here would only run if a was equal to 0. Yeah? So this controls whether the entire program is being run. And one thing, and this is a bit advanced, so come back later on to when you're a bit of a set tree expert already. Normally, when you have a program within a button, then the program runs only for the subject that clicked the button. But if you set a condition, you override this behavior. Okay, so just wanted to mention this here. Come back to this if you need it. At the moment, it's a bit early for that. Now let's have a bit of a closer look at the structure of a given treatment. Each treatment has a background. The background, as you may remember, contains general settings. So if you double-click background itself, it contains the general settings. It also defines the tables that are being used in the treatment. Now, the ones that you see here are all standard tables that are predefined by SetTree, and you shouldn't really modify them. But a table is really what it says. It's a table, a 2x2 matrix, well, containing values, containing rows and columns and values. Now, we already saw the subjects table, which contains all the relevant information for each subject. And we're going to discuss both the subjects table and the other tables in more details a bit later on. But they are defined here in the background. Then SetTree, well, you have an active screen and a waiting screen here in the background, and you again have them in each stage. Now, the active screen in a stage always is what the subject sees while they're active in the stage. And the waiting screen is what they see when they have already finished the active screen of the stage. So, for example, have made their contribution entry, but are still waiting for other subjects to finish their own entries in this stage. And so that's the difference between the two, active screen and waiting screen. And in the background, the screens, they basically contain default elements that we can use later on in the stage. For example, by default, the waiting screen contains a text that says, please wait until everybody else is finished, something like this, or please wait until the experiment continues. And by default, if you don't make any specific setting in your stages, then it will use the waiting screen from the background. Also, the active screen in the background contains a bar at the top of the screen that says this is period 1 of 10 and time remaining is. Now, this is defined in the active screen in the background, but you can turn off that SetTree uses this active screen in a given stage and program your stage differently. Yeah, so these are just default screens that you can override by the screens that you program in your particular stage, and I'll come back to how you do that. Furthermore, the background contains programs that run at the beginning of a period. So SetTree goes through this step by step, looks at does the definition set in the background, creates these tables, runs these programs here. Well, this program here is singular, but there could be more than one. It runs through all of them. And then it defines the active screen and the waiting screen that are used as the default later on. Now, for the individual stages, as I said, they can be considered as the screens that are displayed to subjects. And stages, again, can contain programs that run at the beginning of the stage before the screens are being shown. So if you remember in our public goods game example, we had the profit calculation in a program at the beginning of the profit display stage, and the profit display stage thus calculated the profits and then immediately showed them on the active screen. Now, my recommendation to you is to define parameters in the background, in a global stable program in the background. So for example, in my experiment, I sometimes, so let me take a step back. In the stage definition, you usually have a timeout that is by default 30 seconds, which means the stage is displayed for 30 seconds. And if subjects don't have to make any entry in this stage, then after the 30 seconds have elapsed, they go on to the next stage. Otherwise, they get this blinking message saying, please make your decision now. But instead of putting 30 in here, we can actually put a variable in here, a variable that is defined in a global table program in the background. And global table means that here in the when you create your new program, you set the table equal to globals. And don't worry, we'll discuss this in more detail later when we talk about the tables. But if I set the variable timeout here to 30 and then in my stage definition put the timeout as timeout, then the stage will last 30 seconds. Yeah, and that will be the same as if I put 30 in here, but it also has some advantages. I'll come back to that. Or I can say the maximum price for the stock in my market experiment should be 10,000, or it should, the display limit transactions variable, which sets the number of transactions that are displayed on screen, is set to 2, and so on. So all of these general parameters that are for every subject the same, these should be defined in a globals table in the background. And furthermore, one very important message from me is to always initialize every variable in the background. So every variable that you use anywhere in your experiment, I will initialize in the background, and I would also explain a bit. So have some comment with the double slash at the beginning, slash slash. You can start a comment. Whatever you write here, Setri will ignore. And that allows you to tell yourself, your own self in the future, when you come back to read this program 3 months after you first created it, what you were actually doing, what these variables actually mean, or these variable names. And it is important to define, to initialize, to set an initial value for each variable in the background, because if you don't, and then later on you use a variable name and it's not predefined, and it should be, so it needs to have a value but doesn't have a value, Setri will generate an error. But unfortunately, Setri's error message in this particular case can be pretty uninformative. So normally Setri will quite nicely tell you where your problem lies if you have a problem in your code, but not so much for the case where you're using a variable that should have a value but was never assigned a value. And that's why I always initialize every variable in the background, then you don't ever run into this problem. As you can see here, this is this example with the precision and the maximum price for the stock. So here I have an item where you need to enter the price, an input item where you need to enter the price for the stock. And as the layout, I use precision. I'll come back to what this means later. And as the maximum stock price, I use this maximum price stock. And this way, I can change once in the background the maximum price here. And even if I use this in 20 different items, all of these will be updated to correctly reflect the new maximum price for the stock. Something else that I find very helpful is to use variables to switch between different modes of operation in your treatment. So for example, in a market experiment, I sometimes offer subjects an option market to trade in and sometimes not. And instead of programming 2 different treatments, I just program 1 treatment and use 1 variable that I put into the globals table in the background. And I'll come back to what the different tables do. But that I put there, and that I can set to 0 or 1. And then I have the option market in my experiment, which is contained in a box. And this box is only displayed when the option market exists variable is set equal to 1. Once again, display conditions as well we will cover a bit later in the course. Furthermore, I like to have a variable called test mode, or maybe even multiple such variables that allow me to switch between the real experiment mode basically and a test mode where I can switch off certain parts of the experiment to make the testing faster. That means that some screens, for example, can be skipped in the experiment, or some entries that you have to make can be skipped such that it makes testing much easier and faster. Now let's take a closer look at the calculation of payouts. And much of this is specified in the background. Remember this dialog box? Well, here we can make a number of settings that impinge on the payouts to your subjects. First off, we set the number of periods. And we can distinguish between practice periods and paying periods. Practice periods are run before the paying periods, and they do not count towards subjects' payment. So whatever they earn in these practice periods is not added to the payment at the end. Now the paying periods, as the name already says, of course, count for payment. And if you set the treatment, for example, to have 5 paying periods and 2 practice periods, then the practice periods get the numbers -1 and 0, and then the paying periods start from 1. Paying periods always start from 1 and run to the number of paying periods. Now the exchange rate, as I mentioned in the public goods game experiment, is the value in real currency of 1 unit of the experimental currency. So it says francs here, but you can basically substitute any currency you want here, but ECU stands for the experimental currency. The lump sum payment is a fixed payment that is added at the beginning of the first period and is specified in experimental currency units, whereas the show-up fee is also added at the beginning of the first period, but is specified in actual currency units, so real currency units. When you click the bankruptcy rules button in the general parameters dialog box, you get the bankruptcy rules dialog box, as you can see here on this slide. And this is there for handling cases where subjects have negative profits. And there are multiple ways you can deal with that, and that, of course, depends on what you want to have for your experiment. You can let your subjects invest their show-up fee and give them the option to make this choice. And you give them this option by specifying this question here. You can also just ask them to whether they want to go on with a loss or not. And if they do want to continue with the loss, then what happens is that the experimenter has to give them some extra money for them to be able to continue. And I'll not go into too much detail on this now. Basically, I'll stop here, because in my experience, this is a rare case that you need bankruptcy rules. So in most experiments, there is bankruptcy is ruled out. You cannot go bankrupt. You cannot have a negative profit. If you really need that, I suggest you look it up in the manual where you will find all the rules for how to deal with this situation. Now, how does SETRI calculate the profits of a subject? Well, you need to fill in the profit variable in the subjects table. This is exactly what we did in the public goods game. So in the subjects table, there is a variable called profit, and whatever you write, whatever number you write into this profit table is interpreted as experimental currency units and is added to the subject's total profits. And this is a total profit is the proper variable name in SETRI for this, that gets paid out to the subject at the end of the experiment, converted into real currency. So total profit contains all the profit from previous periods summed up, and profit is where you should write the profit for the current period. Now, at the end of the session, the so-called session table holds relevant variables. The first of them is final profit, which is the subject's profit, basically total profit without the show-up fee. Money added is the money that you added to a subject who faced bankruptcy but was allowed to continue, so the money that the experimenter gave them extra. And money to pay then is final profit plus the show-up fee plus money added. So this is basically what you need to pay the subject, of course, again, converted to real currency units. The next thing I want to cover is creating a stage. Now, the first thing you need to know when you create a stage is that the name needs to be unique within your treatment. So you cannot have multiple stages having the same name. The reason is that the names are there for you to distinguish the stages, particularly in the clients table. Clients table always shows you the clients and the stages that they're in, and so the name must be unique, otherwise it wouldn't really help you. And now I want to go through the start condition that you can set when you create a stage, the timeout, and then within the stage, things like the active screen, the waiting screen, and some options that pertain to them. So let's create a new stage. We select the background and then we click Treatment, New Stage. And in this dialog box, as I said, the name must be unique. You cannot have multiple stages of the same name. And then you can set the starting condition. The default starting condition is wait for all, which means that all subjects need to be finished with all stages prior to this current stage, such that everybody can enter into this stage at the same time. Everybody then sees the screen at the same time. Remember, in the public goods game experiment, we had people who had already made their contributions saw a screen that said, please wait for the experiment to continue, while the other subjects were still making their choices. And only when everybody had finished, everybody moved on into the profit display stage. And in the public goods game, this was essential because for people to see their profits, everybody in the group at least had to have made their contribution decisions. So wait for all is the default setting. You could, however, also set the stage to start if possible. And what this would mean is that whenever a subject comes here, no matter whether the others are done yet, the subject can immediately see this screen and continue with this new stage. And you can click Start If and actually set a condition for subjects to enter this stage. So something like A equals 1, for example. You can also decree that Sentry should only let a maximum of one person per group into the stage. So this is for some special experiment types. Now the timeout setting. The default timeout setting is that the stage lasts for 30 seconds. And after 30 seconds, you can set whether the subjects should automatically be kicked out of the stage into the next stage or not. Or you can leave the default behavior, which means they're not kicked out if there is an input item in this stage. So if subjects have to actually submit a choice or make an entry, and they are kicked out if subjects do not have to make a choice. And we saw this in the public goods game experiment where we didn't touch this default because it was actually fine for us. What happened there was that in the contribution entry stage, subjects had to make a choice such that when the 30 seconds ran out and they still hadn't made their choice, the screen would stay as it was. It would just start blinking a message saying, please make your choice now or something. However, in the profit display stage, where subjects did not have to make an entry, a choice, they just had to view their results and could click the continue button. There, the program automatically, after 30 seconds, continued on, and in this case, since this was the last stage, moved on to the next period. Okay, so let's create our stage here. And now in the stage, there is the active screen and the waiting screen. And the active screen shows people or contains what people see while they're active in this stage. So in our public goods game, here we put the box that showed them their endowment and asked them to make their contribution, for example, in the contribution entry stage. If you double click the active screen, you can see that so I'm not going to talk about this down here, I've never used it, but this is an important option. Here it says by default, background screen is being used. And what this means is that if you go to the background, you also have an active screen there. And if you double click that one, if you look at that one, it contains a header box. And in the header box, you can specify the name of what period means, the term out of, the term for trial. So basically you set here what subjects usually see at the top of their screens. Remember there it says period 1 of 10 and it says remaining time and so on. Well, it says that if you've switched it to English or if you've changed these terms here. Otherwise it uses the German terms that you can see here. And you also see this message that starts blinking, bitte entscheiden Sie sich jetzt. This is German language. Please make your decision now would be the English version of that. And you can see, well, no, let's skip that and come back to the positioning of the box later on. The only thing I want to say here is that the header box is always positioned at the top of subjects' active screens. So if you remove this little tick mark here, subjects would not automatically see the header. So in the stage where you don't have this set, they would not see the header box. Furthermore, in the waiting screen, it also says background screen is being used. And in the waiting screen in the background, we have a little box that just contains one item. And this item says, please wait until the experiment continues, or bitte warten Sie, bis das Experiment weitergeht, the German version. This depends again on which language you set your set tree to. The final thing I want to go through in this chapter is loops in set tree and the options you have there. Now the first loop is a bit specific to set tree, which is the do function, the do table function. And what it does is it takes a set tree table. Remember, set tree tables are just like any other table. They have rows and columns. And what the do function does is it takes every row of a table and performs a command on this row. So this first command here would go to the contracts table, and in every row of this table, create or modify the variable player and set it to, well, colon subject. Now I'm not going to talk about what the colon means yet. We'll come back to that later, but it basically sets it to the subject, to a subject number. Let's leave it at that. And since it does this for every row in the table, that's why it is a loop. Now, a more typical loop that you find basically in every programming language is the while loop. And what this while loop would do is it would first off check whether I, the variable I, is less than or equal to 5. And then it will perform whatever is between these curly brackets, which is in this case to increment I by 1. Once it has done this once, it goes back here, checks whether this is still the case. If so, it will again do that. If not, it will go to the next line in the code. Now, with a while loop, there is always the risk of creating an infinite loop. So you need to make sure that within these curly brackets, you have something that makes sure you can at some point get out of this loop. The repeat loop is very similar to the while loop. The only difference is that the repeat loop first does what is in the curly brackets and then checks whether it should do so again. So it first increments here and then it checks whether it should again increment in the next round, basically, or go to a next round. The for loop, also basically available in every programming language. The for loop in set tree, or the syntax here is that it takes a variable I or creates a variable I and tells set tree to start at the value of 3. So basically write 3 into I and then run this piece of code and then increment this by 1 to 4 and again run this code to 5, 6, and at 7 it again runs this code and then it stops. Typical for loop. So if you just say for I, 3, it would run, I would be set to 1, 2, and 3, and each time this would be executed and then set tree would go on. Check out the manual for the exact syntax. There are even more options available. And finally, a bit of an unusual loop. You can have a loop in time, so basically tell set tree to repeat something after a certain time has elapsed. And that is done using the later command. If you tell set tree, or if you use in your code later, then you put some number in here. Those are the seconds that Z3 should wait. And do, then Z3 does this exactly once. If you say later the seconds and repeat, then Z3 repeats whatever is in the curly brackets every n seconds, where n is what you put in here. So in this case, later 15 do would, after 15 seconds after Z3 encounters this command, do whatever is in the curly brackets. Or if you say later 15 repeat, it would every 15 seconds do what is in the curly brackets. And finally, if you're in a while or repeat loop that is, well, that doesn't end, that's an infinite loop, then you can use Control Alt F5 to break out of this loop.